Some of you may have heard of this thing called Science-Based Targets Initiative. So that's a corporate net zero standard that emerged very recently. So I'm just going to very briefly summarize this report here called SBTI Corporate Net Zero Standard version 1.0, released in October 2021. It had a history, basically started in 2020, where they started with the publication of the Net Zero Foundation's paper, and a balanced and diverse group of 42 experts from civil society, academia and business has guided the development of the standard, which then took the initial draft form, and first public consultation was held in February-March of 2021, where nearly 400 participants from 37 different countries and a variety of sectors participated in the first public consultation. Later in the summer, the road testing process was done. 84 companies participated to trial the target setting tool, review the criteria and guidance, and provide feedback. Second public consultation happened in September-October with 167 participants participating in the pre-launch consultation, and the launch happened in October-November of 2021. So we'll just look at some key messages from the report, starting with this one. Key elements of the net zero standard: they have the short term and the long term, so 5 to 10 years out to 2030, we're almost there, and by 2050 at least, looking at abatement within the value chain, removals here, abatement or removals beyond the company's value chain, and net zero emissions shown here with the blue diamond. Value chain basically is about production, marketing, and maybe services after that in terms of guarantees and so on and so forth. So looking schematically at the emissions in tons of CO2 equivalent, a base year is chosen, required to be chosen. Then there is a 5 to 10 year target, and then there is a way to hit their 1.5 degree C aligned emissions pathways by 2050 at the latest. So it can happen before, but you cannot go beyond that. So here, to set near-term SBTs, science-based targets, 5 to 10 year emission reduction targets in line with the 1.5 degree C pathway. Set long-term SBTs, so target to reduce emissions to a residual level in line with the 1.5 degree C scenario by no later than 2050. Beyond the value chain mitigation, in the transition to net zero, companies should take action to mitigate emissions beyond their value chains. For example, purchasing high quality jurisdictional RED plus credits, so that's reductions of emissions from deforestation and forest degradation, or investing in direct air capture and geologic storage. So this looks like some room for offsets, which is not always a great thing, because honestly, if everybody started doing it, there is not enough space on the planet to accomplish the offsets. Neutralization of residual emissions here in step 4. Greenhouse gases released into the atmosphere when the company has achieved their long-term SBT must be counterbalanced through the permanent removal and storage of carbon from the atmosphere. So SBTI perspective on prioritization of mitigation actions. Emission reductions are key to transition to global net zero, but beyond value chain mitigation can accelerate this transition. So looking here at complete an emission inventory following the GHG protocol, set near and long-term science-based targets to reduce value chain emissions, implement a strategy to achieve science-based targets, disclosed target progress annually. So monitoring, reporting, verification are critical steps, as must be, to make sure these are actually being met, the targets are actually being hit. In the near term, prioritize securing and enhancing carbon sinks, so terrestrial, coastal and marine, etc., to avoid the emissions that arise from their degradation. So this is, again, sounds like offset, but whatever works is okay at this point. There is also a critical need for companies to invest in nascent greenhouse gas removal technologies like DAC. In the long term, when the net zero target date is reached, companies must neutralize any residual residential emissions by permanently removing carbon from the atmosphere, companies must continue to neutralize any remaining emissions. So this is schematically then choose a base year, set the near-term SBT, which they should be on already, and then hit the long-term SBT to reach the 1.5 degree consistent emissions by 2050. Including the DAC and other offsets. Looking here at a table, summary of the status of sector-specific guidance and pathways for sectors. Where sector-specific guidance is not yet complete, all dates are expected but not binding due to each project undergoing formal SBTI review before completion. Except for power generation and FLAG, that's forest, land and agriculture, all currently eligible sectors may use the cross-sector pathway to set 1.5 degree C aligned near-term and long-term science-based targets. We'll see what cross-sector pathway means in a minute. Currently eligible sectors where 1.5 degree C sector-specific pathways are planned but not yet available are strongly recommended to use the cross-sector pathway or FLAG pathway to set science-based targets. For the road and rail transport sector, well below 2 degrees C aligned sector-specific pathways are available. So the color codes and the symbols in the next table are green is where guidance is complete, and star is where 1.5 degrees C sector pathway is available at net zero standard launch during October 2021. The orange colors are where the pathway is planned and guidance release date is known. The gray and darker orange correspond to sector using cross-sector pathway, and guidance is planned but no timeline is available. So try to map those onto here. IPCC terminology was agriculture, forestry and other land use, buildings, industry, transport, other energy, electricity and heat, and other sectors. In the science-based targets, they mapped it onto forest, land and agriculture or FLAG pathway, FLAG commodity pathways, buildings, iron and steel, cement, chemicals, so they fit into industries here. Transport has road and rail transport, maritime transport and aviation. Oil and gas are the other energy. Power generation is under electricity and heat, and other sectors include apparel and footwear and internet and communication technologies here. So here are the various things for each one of them. Pathway, near term and long term, so available with guidance already complete, and so on. And the near term dates starting March 22, December 21, June 22, December 21, where pathways, so if you look here, sector pathways planned and guidance release date is known. So there are some for road and rail transport. Cross-sector pathways have to be used and guidance is planned but no time is available, and so on. In terms of guidance, the document, a guidance document to support, the dates are known: March 22, March 22 not known, April 23 not known, already available, and so on. Okay, so it's quite a good mapping to cover a lot of the industries. Summary of how the cross-sector pathway and sector-specific pathways can be applied. Which companies can use these pathways? What types of targets can be modeled? So we are looking at cross-sector pathways and sector-specific pathways. So in terms of near-term and long-term, in both cases, cross-sector pathway, all companies except those in the power generation sector and FLAG sectors. And the modeled targets here are absolute or intensity, so either total amount of emissions in tons CO2 equivalent has to be reduced, or intensity in terms of tons of CO2 equivalent per some quantity of production or some such thing, as we will see in a minute. In sector specific pathways, for scope 1, typically companies in heavy emitting sectors or a FLAG sector. Scope 3, companies with scope 3 emissions dominated by one or more heavy emitting sectors or FLAG sectors. I think you know what scope 1 and scope 2 and scope 3 are. In case you don't, briefly, scope 1 and scope 2 are the emissions from your input supply chain and your production. Scope 3 are what happens after you produced your good and you have shipped it out, and then it's being emitted by the users, consumers, and so on. So for the flag sector here, absolute or intensity is for near term and also for the long term, and for all other sectors intensity, but for the long term it's again absolute or intensity. Looking at cross sector pathways then, gigaton CO2 equivalent from 2020 at 40 gigaton CO2 equivalent by 2050. There is some residential as it's called. So you can look at the sector specific intensity pathways for cement, iron and steel, power, residential buildings and service buildings. It's pretty steep pathways required to hit the 1.5 degrees C consistent pathway by 2050. In terms of sector specific long-term science-based targets, flag sector 80% reduction, power, so it is intensity as well as absolute. So here we are looking at intensity and percentage of absolute reduction over 2020 to 2050. Cement, both have to be reduced. Iron and steel, the intensity is allowed more than the absolute, so 91% reduction in absolute and 0.11 ton per CO2 per ton of steel in terms of intensity. Service buildings again, 0.18 kilogram CO2 per meter squared of the area and 98% in terms of absolute reduction, similarly for residential buildings. The SBTi recommends a 5-step approach to setting science-based targets. Select a base year, calculate your company's emissions, set target boundaries. So this could be operational boundaries or financial boundaries, equity shares, and so on. Choose a target year and calculate the targets, and then you get on the road with your near-term science-based target and long-term science-based target. So this is a visual explanation of the expansive boundary approach the net zero standard takes to scope 3 target boundaries. 67% boundary for near-term targets over the 5 to 10 year time scale. So this is the expansive boundary, so 90% boundary for long-term targets by 2050. So here are the emissions. Choose the base year where your emissions plateau, and then they have to start dropping with the near-term science-based targets and the long-term science-based targets out to the long term, instead of in terms of having hit the 1.5 degrees C consistent emissions either by 2050 at the latest or before. Okay, minimum boundary coverage for near-term targets and long-term targets. So near-term and long-term. Minimum percentage boundary coverage by scope. So greenhouse gas inventory boundaries have to include scope 1 plus 2 and scope 3, and there are various percentages required for near term and long term. Special boundary coverage requirements by emissions source. So emissions source include use phase emissions from sold or distributed fossil fuels, so it's beyond your scope 1 and 2. Direct CO2 emissions from biomass combustion, processing and distribution, as well as land use emissions and carbon removals from bioenergy feedstock. So this, for example, here both long-term and near-term required an absolute contraction target, and this must be included in target boundary in terms of direct CO2 emissions. Sector-specific target boundary requirements and greenhouse gas from land use change, excluding bioenergy, optional to include. Okay, so I'm not reading all the details, but you know what we mean. For example, for the near-term and long-term targets, transportation companies must set targets on a well-to-wheel basis, and power generation companies must set an SDA target on scope 1 power generation and all sold electricity if scope 3 coverage is required. So lots of these kinds of details exists. Looking at the ambition ranges for target classification of near-term science-based targets, which is critical to hit. Long-term temperature goal are well below 2 degrees C with 66% probability by 2100, and 1.5 degrees C is allowed a lower probability of 50% by 2100. And these require annual linear reduction rate over the target period for near term in the range of 2.5 to 4.2, but the lower limit we must hit greater than 4.2% linear target per year. Okay. Summary of eligible methods for near-term and long-term targets. Again, many details which I will not read. Here is long-term, near-term, long-term, and eligibility. So determines what are the things involved, like scope 1 to 3, most commonly used heavy emitting sectors and the flag sector, and so on. So absolute contraction, cross-sectoral pathways, physical intensity coverage, renewable electricity using renewable energy certificates and virtual power purchasing agreements, engagement, so suppliers or customers to set science-based targets at a minimum ambition of well below 2 degrees C in the near term, and economic intensity, at least 7% per year-on-year reduction of emissions per unit value added in the near term, and 97% in the long term. Physical intensity, at least 7% year-on-year reduction for a company-defined physical emissions intensity metric, and 97% for the long term. Here only scope 3 are involved, for example. Okay, so you can sit down and look at those more carefully if you're involved in this kind of work, or if you're from an industry that is looking at these science-based targets for your sector. A comparison of boundary, ambition, time frame, and methods between near and long-term targets. So boundary, ambition, time frame, and methods. What percentage of emission inventory coverage is required? What is the ambition level in terms of limiting temperature rise? What is the maximum time frame to meet the target? And what are the eligible methods to set targets? So look at near term for scope 1 and 2. Boundary is 95% of the emissions. Ambition is 1.5 degrees C. Time frame is 5 to 10 years. Methods eligible: absolute contraction, physical intensity convergence, renewable electricity. And similarly for scope 3, if greater than 40% of the total emissions, then 67% coverage. This will hit only 2 degrees C target, and again 5 to 10 years. Here absolute contraction is eligible, physical intensity convergence, engagement, economic intensity, and physical intensity. Similarly for long-term SBTs, scope 1 and 2, scope 3, in terms of the boundaries, 95% and 90% of the emission inventory coverage is required to hit the 1.5 degrees C target. 2050 by the latest, and 2040 for the power sector, with several methods being eligible here. Okay, so that's a brief run through, but gives you a good sense that a pretty stringent near-term and long-term targets, science-based targets, are set for all sectors mentioned here in terms of reducing emissions to science-based targets, which are 1.5 degrees C warming with 50% probability by 2100, and 2 degrees C by 2100 with 66% probability. Okay, so these will keep evolving, I suspect, based on the progress on the near-term targets, and especially in terms of technological promises on DAC and other carbon removal methods. Okay, so let's keep an eye on that as we go forward. Okay.